James Webb Space Telescope discovery in Proxima b will shock the world. NASA's new James Webb Space Telescope may be able to detect evidence of artificial light on the nearby exoplanet Proxima b, astronomers predict. The study, by a team including controversial Harvard astronomer Webb, suggests that the optical telescope can be configured to spot evidence of LED light on the planet Proxima b, orbiting Proxima Centauri 4.2 light-years from the Earth. Before we get into the video, do like the video, subscribe to the channel and hit the bell icon. Proxima b was discovered in 2016 and is thought to be a rocky terrestrial planet slightly larger than the Earth, that some scientists predict could contain liquid water. It orbits very close to its small red dwarf star, so is likely to be tidally locked with a permanent night site. And Webb suggests that a civilization may deploy powerful mirrors or require very bright LED-style lights to illuminate their cities. They suggest that using the near-infrared instrument on the James Webb Space Telescope and looking for the telltale signs of LED light waves in the light from the planet and its host star, they will be able to detect this artificial light if it exists. Artist's rendering of Proxima Centauri system, portrayed on the right, Proxima C orbits for about 5.2 years around its host star. The system also comprises the smaller Proxima b, on the left, discovered in 2016, that orbits in the habitable zone closer than Mercury is to the Sun. NASA and partners plan to launch their major next space telescope later this year, and it will serve as the natural successor to Hubble. Primarily an infrared telescope, it will have a wider spectrum view than Hubble and operate further out from the Earth, in a solar orbit rather than an Earth orbit. The James Webb Space Telescope and most of its instruments have an operating temperature of roughly 40 Kelvin. This is about minus 387 degrees Fahrenheit, which is negative 233 Celsius. When it is launched in 2021, it will be the world's biggest and most powerful telescope, capable of peering back 200 million years after the Big Bang. James Webb is designed to last for 5 years, but NASA hopes it will operate for a decade or more. The telescope is set to launch on a European workhorse Ariane 5 rocket at the end of October 2021, with the first observations expected in 2022. Professor Loeb has spent more than a decade predicting the existence of aliens and suggesting ways they may be discovered. He is involved in the Breakthrough Starshot project to send laser-boosted light sails on a trip to Proxima Centauri at high speeds, reaching the star in decades. The astronomer also wrote a paper claiming the interstellar asteroid Oumuamua was humanity's first contact with an artifact of extraterrestrial intelligence. He is now turning his attention to Proxima b, which for many alien hunters is a prime candidate in the hunt of signs of intelligent alien life outside the solar system. The planet is 1.27 times the size of Earth, sits within the habitable zone of its star, so may have liquid water on the surface, and is just 4.2 light-years away, which in interstellar terms is practically on our doorstep. However, as the star is relatively small, this habitable zone is close to the star, meaning the planet is tidally locked, with one side always facing the star. There is also speculation that it is very unlikely life could develop on the day side due to a constant stream of intense radiation from its host star. Proxima b, orbiting just 4.5 million miles out, or about a tenth the distance of Mercury's from Sun at its closest point. Radio signals have already been detected from the area around Proxima b. However, radio astronomers believe this was likely just interference from the natural sources. It is the tidal locking that prompted Professor Loeb to consider the possibility that LED lights may be detectable from Earth with the powerful James Webb Space Telescope. Due to launch later this year, the James Webb Space Telescope will have a wider spectrum view than its predecessor Hubble and operate further out from the Earth, in a solar orbit 930,000 miles from the Earth. The team investigated whether artificial lights could be detected on the dark side of Proxima b by computing light curves from the planet and its host star. The two different scenarios we consider are artificial illumination with the same spectrum as commonly used LEDs on Earth, and a narrower spectrum which leads to the same proportion of light as the total artificial illumination on Earth, they said. We find that the James Webb Space Telescope JWST will be able to detect LED-type artificial lights making up 5% of stellar power. Our predictions require optimal performance from the near-infrared, spectrograph, NIR spec instrument, and even if not possible with JWST, future observatories like LUWAR might be able to detect this artificial illumination, they explained. LUWAR, or the Large UV Optical IR Surveyor, is a concept designed for a major new multi-wavelength space observatory being considered by NASA. A mysterious radio signal from our nearest stellar neighbor, Proxima Centauri, is being carefully investigated. Researchers from the Breakthrough Listen project have been studying radio waves since April 2019. The signal was spotted by the Parkes Radio Telescope in Australia in April or May 2020, and unlike previous radio bursts, hasn't been attributed to any Earth-based or near-Earth human-created source. This signal likely has a natural explanation, but that hasn't stopped alien hunting astronomers from listening more closely. If James Webb can detect the narrowband light that is reminiscent of LED bulbs, it will be because it will be able to characterize the atmosphere of the planet. Advertisement. Doing so will allow researchers to use instruments on the observatory to detect how much energy transport occurs on the planet, and then perform calculations of light curves to determine whether they match those of an LED light source. To conclude that it may be able to detect artificial light, Loeb and colleagues use the James Webb Space Telescope Exposure Time Calculator. This tool allows astronomers to predict what can be detected in any given period based on predefined settings, before the observatory launches. It allowed them to determine the likelihood of detecting different flux values, and detecting those with a wavelength that matches artificial light levels that should be expected from a civilization living in permanent darkness. Proxima b is tidally locked, and if it has a permanent day and night side, the civilization might illuminate the night side using mirrors launched into orbit or placed at strategic points, the authors wrote. In that case, the lights shining onto the permanent night side should be extremely powerful, and thus more likely to be detected with James Webb Space Telescope. We have found that James Webb Space Telescope will be able to show the existence of artificial illumination for standard LEDs 500 times more powerful than those currently found on Earth's. And for artificial illumination of similar magnitude to Earth's, an unrelated study, also exploring the potential uses of James Webb Space Telescope, suggested it could spot signs of alien life as soon as 2026. It can detect signatures made by living creatures, and Ohio State researchers say it could find life on another planet in under 60 hours. The long-delayed JWST is set to launch by 2018, originally in 2011. Loeb explains that if a rocky planet like Proxima b has an atmosphere, it would absorb light from its star and re-emit it as infrared light. Incidentally, the JWST is specifically designed to observe infrared light. The JWST can take photos of infrared light on the surface Proxima b, looking for patterns that would confirm whether or not this exoplanet is water or is covered by an atmosphere. Things aren't so simple, however. The proposed method may be doable, but other factors have to be considered. For instance, the existence of an atmosphere may not guarantee life, says astrophysicist Ed Turner of Princeton University. Proxima b may be like Venus, with an atmosphere 90 times thicker than ours and extreme heat. Still, Loeb's and Kreidberg's plan is the only option we have for a glimmer of an answer about this Earth next door. Okay guys, that's pretty much it for this video. If you liked the video, please like, share, and subscribe. We'll see you at the next one.